We'll look at finding the linear regression model, sometimes called the line of best fit, and we'll use the data where we have the number of years since 2002 and the number of deaths due to drug overdoses in thousands. We're going to use x equals 0 and 2. Okay, so the year 2002 is an x value of 0. 2005 would be an x value of 3. 2008 would be an x value of 6. And so on. Okay, so what we'll do is we'll enter those values into our list. Okay, so we'll do stat, edit, so press enter. Put the values into your list. And remember 0 is the year 2002 that had 23,000 deaths. An x value of 3 representing the year 2005 had 30.2 thousand deaths, or 30,200, and so on. Okay, we'll come back to that in a minute. So we have those entered in. And the next part here, when we're writing our equation for the linear regression model, we use y hat, given by the symbol y with that little mark over it. Okay, we pronounce that y hat. We recognize that as the predicted response value given an explanatory variable x. So if we're given the year, we can use that to predict the number of deaths that we'd expect. Okay, so our line, y hat equals a plus bx, will pass through the point x bar, y bar. So if we find the average of the x's and the average of the y's, our line will actually pass through that point. The slope of that line, so the number in front of x, that's a slope. You're probably more familiar with y equals mx plus b, but this is just how we do this in statistics. We just use a slightly different equation representing linear, a plus bx. Okay, so the slope is b equals r, which is our correlation coefficient, which we can find on the calculator, times the standard deviation of the y values divided by the standard deviation of the x values. And we'll find those using our calculator also. The intercept, so the a value in this case, is y bar minus b, which was the slope, times x bar. So this is just a bunch of finding the values in your calculator and then plugging them in to the equations here to get the slope and the y-intercept. Okay, so for the slope, we want to find the r value. Okay, and we should have done this in our correlation video, but we'll do it again just to practice it. So we have our values in list 1 and list 2. So we're going to press stat, calculate. Okay, we're going to scroll down to the linreg, a plus bx. Press enter, and then list 1, comma, list 2. And that gives us our r value of 0.9962. Okay, so that's what r is. Now I just used 0.996 on my answer key. And then we need to find the standard deviation of the y's and the standard deviation of the x's. Okay, to do that, we'll go back to our stat menu. And now we're going to calculate. We're going to use 2 var stats because now we have 2 variables. We have the year is one variable and the number of deaths as our second variable. Okay, do not confuse this with the frequency distributions where you had one variable x and the frequency that it occurred. That's only one variable, even though it's in 2 different lists. Here, we actually have 2 variables. Okay, so we're going to use 2 variable stats. Press enter. And L1, comma, L2. Because that's what our variables are in. And you notice here, it gives us x bar, our sample mean. S of x, our sample standard deviation, which is what we need in our formula. So the standard deviation of the x's is 4.680. So I'll put that down in the denominator. And then if I scroll down, notice it also gives me y bar. Okay, so y bar is 38.4, so the average number of deaths was 38,400. And then as I scroll down more, it gives me S sub y, the standard deviation of the y's, 10.018. Okay, so that's what I'll put in the numerator there, 10.018. Okay, do those calculations, and we end up with a slope of 2.132. Okay, so the b value is 2.132. Okay, and then to find the intercept, we're going to use y bar minus b times x bar. Well, again, we already found x bar and y bar by doing our 2 var stats. So y bar was 38.429. So I just wrote that off to the side here. And then x bar was 7.286. So I wrote that off to the side here. Okay, so if we substitute those values in to our intercept equation here, 38.429 minus our b value times the x bar, put that right in our calculator, and you end up with 22.895. Okay, so using the formulas, our regression equation is a, which is our intercept, plus bx. So y hat equals a, which is 22.895, plus 2.132 times x. Okay, so that is our linear regression model or line of best fit. Okay, and the good news is we can use technology to find the equation of the least squares regression line. And we've already done it a few times now. But we go to stat, calculate linreg, a plus bx, and then L1, comma, L2. And notice that our values are very close to what we have in our equation. A plus bx is right here. A is 22.893. Now, so we are 0.002 off. That's just from rounding along the way. So we rounded the standard deviation and the R value. Okay, those are rounded values. And then the 2.132 times x is what your b value is for the slope, 2.132. Okay. And the bottom here is just a reminder that if the r squared and the r value don't show up, just go to second 0 and to your catalog and scroll down until you find the diagnostics on, and make sure you turn those on. Okay, the next thing we'll look at, question 2. We write the equation of our linear regression model, round coefficients to the nearest 100. Okay, so I rounded those. And then we need to recognize we have a linear model now. And if you, in other math classes, you may remember that a linear model has a slope. So the coefficient of the input, or x in this case, is the slope. And we need to be able to interpret the meaning of that. We also have a y-intercept, or a vertical intercept. We have to be able to find that and interpret the meaning of that. Okay, so once you have a linear model, there's all kinds of different questions you can be asked. The other few questions you can be asked, given an x value, so given the number of years since 2002, can you find the predicted number of deaths? Or if you're given the predicted number of deaths, can you use that to find what year you would predict that to happen in? Okay, so number 3, the slope of the model and explain its meaning. Well, the slope is 2.13. And remember that slope in general is the change in y over the change in x. So that's the change in y over the change in x. Well, the change in y in this case is the number of deaths in thousands. And the change in x is just the years that go by, okay, so over the number of years. Okay, so when we look at 2.132, or 2.13, we have 2.13 thousand deaths per year. So all the slope is telling us, because it's positive, we know the number of deaths are going up by 2.13 thousand per year. Okay, so the number of deaths increases by 2.13 thousand per year. Okay, the next question, use our model to predict the number of deaths in 2017. Well, 2017 is a year, and it's 15 years since 2002. Okay, so if x equals 15, you plug that into your equation to find y hat, which is the predicted number of deaths. And when you do that, you get 54.84. So we would predict 54.84 thousand deaths in 2017, which is 54,840 deaths. Okay, then the last question here, using our model to find the year when you would have predicted 45,000 deaths. Well, now 45,000 deaths is a y hat value of 45. So you set that equal to your equation, and then you solve it for x. And you end up with x is approximately 10.4. And how you interpret this, we don't want to get too detailed here, but basically if you add 10 or 11 to 2002, you get 2012 or 2013. So somewhere in that time period, you would predict about 45,000 deaths. The last thing I want to mention is sometimes you have to be very careful when they define your variable. They could have just as easily said, instead of saying that x equals 0 represents the year 2002, they could have said, let 0 represent the year 2000. And then that would change your x values to 2, 5, 8, 10, and so on. So if they define the variable for you, then you have to be very careful with how you enter it into your calculator.